Good morning, mathematicians. Welcome back to Beanie Boy Math Hour, which will not last an hour. The only channel on YouTube where a Beanie Boy tells you about Galois Cohomology. And by tells you about Galois Cohomology, I mean, attempts to teach themselves Galois Cohomology in real time. So today, I guess we'll get back to talking about the Hilbert symbol. Also, now we all finally know Arad's blog, so we can... you popped into that shortest stream. Yeah. For those of you not in the know, there technically was another stream that was like 2 seconds long. But my video wasn't working, so I had to end it and restart. Bonjour from Canada. Fire Emblem. Comment ça va? So suppose we've got an element that is not a square. What's a claim? You're meaning to watch the last stream. Have not, but want to. Well, it's a beautiful thing about YouTube. They're all the streams are up there. Yesterday's stream actually has a link to Arad's blog post, which would be very helpful in understanding all of this. So definitely check it out. Okay, so anyways, I guess the point of this is that B is a norm in QP adjoining the root of A for all A, or if that is true, then this means the Hilbert symbol is 1 for all A, and that implies that B is a square. It is defined also for R, and Sayre proves the product formula. Oh. What is it for R, though? I vaguely recall this coming up, actually. There was some thing in my master's thesis that involved the Hilbert symbol for R. It wasn't an important thing. I don't think it ever even made it into the thesis, but I remember not understanding it at the time, trying to go read some background on it. I guess I still don't know because he hasn't described the Hilbert symbol for R. Très bien, merci. Et vous? Très bien. You want to get into cohomology and Hilbert spaces, but you certainly have a long way to go. Well, they're both, we're doing relatively fancy stuff here now, but if you have a background in some group theory and some linear algebra, then both of those things should actually be relatively approachable if you find the right resources for them. The general case. Okay, the general case of what? The Hilbert symbol? Or of this proposition? I see. Of this proposition, I suppose. The product formula in number fields is the arithmetic analog of saying the divisor of a rational function has degree 0. Interesting. I get it. Okay. So let's think about the general case. Recall that for every cyclic group G hat and a G module, we have these isomorphisms, which become canonical with respect to a choice of generator. More precisely, if n is this and chi is this, is a homomorphism from the cohomology of this short exact sequence, we obtain a boundary map. And then, and our isomorphism should be given by delta gamma cut product B. Now, K can be any field, and this can be a cyclic Galois extension of order n. In the R equals 0 case, we just get this isomorphism. For chi in this Hom set and B in K cross, we define this thing prime to be, so this is like a pairing from where does chi live again? Okay, it's a pairing from the Hom set and H2 that goes here. Okay. And then we can show that this is a non-degenerate pairing. That's going to be the game plan. Yeah, where are we here in this argument? What is it? What are we trying to show? Hang on, let's go back up. What are we trying to show? Local field containing a primitive nth root of 1, any element of K cross that is a norm from every cyclic extension. Okay. I'm losing the forest through the trees here, though. Okay. So now if we suppose the characteristic is non-zero, we require n to be relatively prime to P. Take a separable closure. And let G be this, roots of unity. Then we take this sequence, and by Hilbert 90, why do we get this from Hilbert 90? Oh yeah, I guess this basically is Hilbert 90, right? H1 G mu n is isomorphic to this quotient. And H2 is isomorphic to this. Oh, I guess it's this is from Hilbert 90, and I guess maybe this is from the cohomology of this sequence, because one of these should be trivial. Okay. Oh, wait a second. This denotes the group of these elements killed by n. Okay, let's go back to theorem 90 for a second. I mean, there's this proposition, yeah. And this. Both of these are from the long exact sequence. Un momento, por favor. Is it clear if I write out the long exact sequence? Oh, because the H1s are 0, right? Yes. Okay, I see. Right. It's because the H1s are 0. Okay. I am with you now. Wait, but then why? This last one is still not quite clear to me. But I guess that comes from the map induced on cohomology by this, and then by long exactness. So, okay, I believe it. Okay, so the cup product gives us a pairing here. Everything is clear when you write it out. Yeah, I do need to write it out. What I do need to figure out, actually, what I should figure out is, I haven't been writing things out as much, but what's the best way to, like, whoa, I don't want to do any of this. Oh, Lord. What's the best way to, some Stavi's World on in the background. What's the best way, to have my my notepad open and this. I do have a second laptop on campus. What I could do is like set it up and have chat open. No, I don't know. Yeah, I guess I could just have chat open on my phone or something, and then just look at that, and then that would give me more space to like write things out and use the PDF. I gotta do some reorganizing here. Because definitely, I think when I switch over to spectral sequences reading, for sure, I'm gonna want both the PDF open and to be able to write simultaneously on the screen. So, got to think about these things. Anywho, so we've got this pairing. Which is given by the cup product. For simplicity, we assume that chi has order n. And considers subfields given by the kernel. Where do I plan on reading spectral sequences from? Good question. I don't know. I haven't made up my mind on that yet. Could be Brown's cohomology of groups. Could be... I mean, I want something that's really for babies, so I can be nice and dumb and go slow and do a bunch of computations. So I feel like maybe the section in Aloofy could be good. One thing I would personally like to do is walk through the proof. Like, apparently you can derive the 3 isomorphism theorems from spectral sequences. So I suppose I would like to do that. Yeah. I don't know if Aloofy does that though. But I mean, he's more detailed and stuff, so. So the claim is that L chi is a cyclic extension of K of degree n. Ooh, you have a blog post about the four lemma with spectral sequences. Nice. Okay. Well, we might have to take a look at that. Sure, those toy examples aren't so useful. Well, it depends what you mean by useful. Like, yeah, you're not ever gonna do that like in the real world, but I feel like for me, that would help just get used to that would help me, I feel, get used to some of the mechanics of working with them, personally. Yeah. Okay, what is going on here? So chi, we're debeanifying now. We're debeanifying. We need the old noggins getting too warm with all this thinking. Chi has order n. This should be a cyclic extension. And chi induces an isomorphism of its Galois group. Is that true? Sure. Right. Because I guess, yeah, I'm hotting up by the kernel. Sure. Okay. Is it clear that it's surjective? Well, we're assuming chi has order n. What are we assuming about our group here? Oh, it's the Galois group of the closure. Surely it must be. Surely it must be. Yeah, I mean, it's order. Yeah, okay. This is an isomorphism of the Galois group with Z mod n. We take B in here, and then we're going to define this primed pairing to be here, as in step 1. And then we inflate it to G acting on the algebraic closure, which is, hey, why isn't this hyperlinked? This should be injective. Okay, I'll take his word for it. This should be injective. And we induce that, I guess, by the injectivity, that this should be 0 if and only if B is a norm from Lx chi. Okay. I definitely do need to write more things down because this is getting away from me, due exactly to a lack of writing things down. Okay. Step 3, we now assume that this is a local field, so we have canonical isomorphism given here. For chi and B, we now define this to be the image of the cup under the inversion, and this claims that we then have the pairing given here. Okay. So left kernel of this pairing is 0. Let chi be in here. We have to show that if this is 0 for all B in here, then chi is 0. So we have the composite of our Artin map with the restriction, which should be surjective for every finite extension L contained in the maximal abelian extension. And this implies that the image is dense. The image of phi k is dense. Is that immediate? Good morning, Keenan. Good morning. I should maybe think through the case n equals 2 in detail. It becomes very concrete. essentially Kummer theory for quadratic fields. You're probably right. I mean, I think at this point I'm basically just gonna keep pushing through the abstraction, and then at some point behind the scenes, like I said, I'm gonna go back and just make a list of sort of the main theorems, and go through some of the proofs I didn't understand fully, kind of in the background, and then I don't know. We'll see where I go from there. But yeah, I definitely I need to do my homework to make things concrete. And yeah, you're probably right. It'd be good to write out the case of n equals 2. But even at this point, I feel like if I started doing it, I feel like I need to go back. I need to just like write down some of the main results and the sketches of their proof, just to because like if we were at this point in reading the book in a course, this would be much later in the course, and I in theory would have like done a bunch of homework for this already, and so a lot of these theorems and results would be in my mind, and it would be easy to sort of juggle them and to see all the details. But I've been a bad boy and haven't done that writing, so. What should we do next? Yeah, so spectral sequences is up soon. I'm still debating whether or not we spend some time reading Brouwer groups first, because I feel like a lot of this doesn't depend on the other chapters so much, right? Other than cohomology. So I kind of want to go read some Brouwer groups, but we'll see. But maybe I should read through something. Yeah. So I need to figure out what's the best way to put the textbook on screen and write at the same time. And we need to work out and what else? Oh yeah, but also think about what should I read through in the future? What should I read through in the future? I guess that might depend on maybe if there's any postdocs that I end up deciding to do. I'd probably review some subjects relevant to that postdoc and try and go through and understand background material for that. Unless I go to industry, who knows? I don't know. No one knows at this point. Okay, why does this mean that the image is dense? The image of phi k is dense. I mean, vibes based, it makes sense, right? If this composition holds for all the finite, all of these compositions. Okay, I think I see. I get it. Yeah, I mean, I guess all of the finite. If you look at all of the finite, all the elements and all the finite extensions, that should be dense in the big thing. So then, it's still kind of weird though. If it factors through a surjective map on every level, I guess I can believe, right. So I guess what that means is that phi k has to hit everything in all of the finite extensions. Right. Okay. I mean, it makes sense. Again, should probably write things out more carefully, but very believable. Okay, and recall 3.6. Where was 3.6? Right. That was for every chi in here. This holds. Okay. So that was just literally what we were about to quote. It's basically what it says. Because this pairing is like, yeah, the what is it called? The inversion map. So we have this, and because chi is continuous, if it is non-zero on here, if it is 0 on here, then it's 0 on the whole of here, right, by this density argument. Wait, are we assuming... we're trying to show... We're assuming that this is 0 for all b in here. Right. Oh, but this, okay, this formula forces chi to be 0, and so it's 0 on this dense subset, so it's 0 everywhere by a continuity argument. Okay. Whew. Okay, we're almost through this. Step 4. Final step here. Now we assume that K has a primitive nth root of unity. If we tensor the roots with themselves, we get back the roots. So we have some non-canonical isomorphism here. But then we get a canonical isomorphism over here. Not so clear, but to me. Hey, Mr. L. Oh, because mu1 can be interpreted as some... I don't know. But on combining this with this isomorphism given by the invariant map, we then get an isomorphism of these things. So we have a cup product pairing here. I see. For AB in KX, their image in mu n under this pairing is denoted by this, and this pairing is the Hilbert symbol. Wow. Yes, Arad, you're absolutely right. I do need to... Oh, I forgot to make it live chat. I probably didn't miss anything, but... Slipping. Caught me slipping. The canonicity here is not quite about the underlying groups, but rather the Galois actions. I see. Tensoring with mu is like Tate twisting. Yeah, we're definitely gonna have to. I'll have to make at some point soon. I'll have to do one of these live streams where, after I write up my notes, maybe we do like a recap episode. You know, like in Calculus 1 courses before the exams. Sometimes they do a review session for the students, right? I should make notes and then do a review session for myself. Okay, so we get these, I've got this non-degenerate pairings with all of these properties we suspect. Okay, maybe I'll look at this more carefully next time. I think we're going to end things off here. But I like to just scroll ahead to see where we're ending up. We've got some relations with the Artin map. Yeah. Ooh, this is an interesting remark. Hilbert symbol has an interpretation in terms of central simple algebras. See, this really makes me want to read the Brouwer group chapter. define this to be the K-algebra with these generators. Then this is the class represented by this. Wow. Yeah, that really makes me want to read it. But actually, you know what I should do? I need to start applying to postdocs. In fact, there's deadlines coming up very, very soon. So maybe my next couple office hours are going to be really boring because maybe I'll just work on my like teaching proposals and stuff on live stream, and then let people interrupt me with questions. That's probably what I should do. Anywho, that is where we're going to end it for today. Thanks all for joining me. Thank you for the good luck wishes, and QE